And welcome to Ladyada.
Hey everybody, and welcome to my desk. I'm working on a whole bunch of hardware, including some prototypes that came in. So let's get right to it. So let's go to the overhead and I'll show off this TRRS Trinkey. So I remember a few weeks ago I mentioned I have a lot of these SAMD 21 E18s because I had to book 2 years worth of inventory through Microchip. And then they're like, anyways, we're going to ship you all 2 years worth at once. I was like, no, please schedule it out. So it's like every quarter I get some, but it's like, no, they just shipped them all to me at once and I was required to take them. So I have like a lot of SAMD 21 E18s. So it's like time to do more Trinkeys, right? One Trinky I got a request from was from AT Makers for a TRRS Trinkey. And what this has, let me just see if I can, maybe this will be better. I just want to get a nice background here so you can see it. This has a TRRS jack, which is this audio jack. It's an 1/8" jack, but instead of just having stereo, like normally you have like, the sleeve is kind of long and then you have left and right. This has left, right, like tip, ring 1, ring 2, and sleeve. So this is for often used for like headphone, like, have headphone and stereo audio. I don't have like an iPhone headphone jack or whatever, but that's often used for like Android or iPhone jacks. And these are great because you get 4 contacts on, one easy to plug in connector that's easy to use. And like you see here, we sell these easy terminal block to TRS adapters, which I'll use for the demo. A TRS jack connects to the 7021E. There's a NeoPixel. The really nice thing I like about the 21Es is that you need almost no components. You need a 3.3 volt regulator and like 2 caps, and you don't need a crystal because it does USB. The JK pulse, it uses the 1 kilohertz pulse as the PLL for the 12 megahertz internal oscillator. You just need a resist, you don't even need a reset resistor because there's a pull-up built in. You just need a reset button and you're good to go. And I have this programmed with the Tina UF2 bootloader. So, again, you can plug it in and then, I forgot, I don't know where I put them, but you can get headphone splitters. So they'll split this audio jack into like, stereo and mono connectors. So if you want multiple mono connectors, you can do that. Or like I said, just plug this in here. So I'm going to plug this into my USB extender, which I don't know if you can't, I'm going to everything's going to fall apart. So I'm just going to do that. And then I have over here 2 buttons that are plugged in. And then let's go quickly to the overhead. Sorry, the computer. And let me close this. So because it's a SAMD21, I can run CircuitPython on it. Arduino works too, but CircuitPython's great for like quick projects. And there's not a lot of RAM. That's like the only downside. The RP2040 has way more RAM. You could do much more. But like, again, the simplicity of the size and cost, the SAMD21 is kind of great. It's a little demo that uses the keypad and HID libraries that are actually frozen in, so you don't even need any files. Make a NeoPixel. And so what's interesting about this design is what AT makers wanted was that normally the sleeve is always ground. And then you have like, whatever microphone on ring 1 and then, or ring 2, and then left and right on ring 1 and tip. But instead he's like, oh, can you have every pin from the TRS adapter go to a GPIO? And the reason is that there are some accessibility adapters that are potentiometers. And so you need 1 pin to be 3 volts and 1 to be ground. And then the analog input comes in on like the middle pin. But also like, depending on your splitter, like you might have, you want the shared ground. It might be on like the sleeve or it might be on the tip. Like it could be on a couple different pins. And so each pin from the TRS goes to ground, goes to a different GPIO. All of them are analog capable. But it means that what I do is for this configuration, so if you go to the overhead again real fast, I'll just show this. So for this configuration, I have 2 switches. And of course, one, I'm going to use the internal pull-ups. So 1 pin has to be grounded. And so, I'm going to have the sleeve and the ring grounded. And so that this pin here, ring 2, and this pin tip is the input, right? Because it's a switch. You want to have the opposite pin be ground. So when the button is pressed, it's grounded. Okay, so let's go back to the computer. So the first thing I do is set the sleeve and the ring to be ground. I set them to be outputs and ground. And so that way, when I have the tip and the ring 2, the other 2 pins, I make them into pulled up low pressed keypad presses. And then I instantiate an HID keyboard. The thing I love about CircuitPython, one of the demands I made was we have to have it make it very easy to do HID keyboards and mice, because it's like you can do it in Arduino, but it would be great if it was really trivial to do. And then thanks to the keypad library, we just we just have this in the background. This keypad is handling the event stuff in the background. And then when a button is pressed, I just get a report. So what I'm going to do first is I'm going to quickly, great thing about CircuitPython, I'm going to just comment out the part that does key presses so it doesn't like mess up my editor. And then when I have these buttons, when I press them, you can see it's like, oh yeah, you pressed button 1, you pressed button 2, got it. And then to make this into an HID keyboard, you just save it. And then one button, it actually types out the word hello, and the other button, it does a shift key code A. So you can have multiple, you can do Control Alt Delete if you wanted to. And then, again, if I press this button, you can see it's typing out hello. And if I press this button, it types the letter A. So really easy to do accessibility projects with this. And, with all the pins being available, you just configure it however you want. You can have 3 push buttons because you have 4 pins. And so there's 1 ground and 3 inputs. Or you could have 2 potentiometers, 1 power, 1 ground, and 2 pots, or like 1 pot, 1 switch, or 1 LED and 1 switch, and you can do a couple different things. Also, if not maybe in Python, but if you're willing to use Arduino, you can connect an IR receiver into it and have it receive IR, and you just screw the use a terminal block and use like a little through-hole IR receiver, and now you have IR and a switch. You could even do a rotary encoder. Again, in Arduino, I don't think you wouldn't be able to do it in CircuitPython. You'd run out of memory, but you have two pins. So, 2 GPIOs, power and ground, and then, a switch. So you could have a rotary encoder with a push button. So a lot of accessibility stuff available. And then I did a quick, update for the final version. I was like, well, even though, again, not useful in CircuitPython, but maybe in Arduino, I added a right angle stomach UT connector. So, you could plug in an I2C device or just get 2 more GPIO pins, basically. So if you wanted even more AT pins, you could do it. But I thought this would be, kind of handy for accessibility projects. And it's really small. I like how compact it is. So let's go to the overhead, and then I'll show the next Trinky. So yeah, it's very compact. And again, if I did this with the RP2040, it would basically be feather size, because the RP2040 needs so many more passives and a crystal, and capacitors, resistors. It just needs a lot more components, but it's, again, much more capable. It'd be really great if there was an RP2040 that had the flash memory. Okay, you need the flash memory and the crystal. So if it did USB crystal syncing, so you don't need external crystal, and if you could have the built-in 2 megabytes of flash, that'd be so cool. Maybe one day. Okay, so that's Trinky number 1. So this is good. So I just made that one change, moved the NeoPixel over here, and then in the spot over here, there's a little right angle QT port. This is working great, and I think there's a PR. Dan Halbert did a PR to CircuitPython, and then it's got, like I said, Arduino and CircuitPython support. And then the other Trinky, if you remember, is just a pixel Trinky that will let you connect, in this case, dot star, but you can have 2 NeoPixels or one's a dot star LED. Same basic layout. You'll see it's almost identical. SAMD21 reset button. 3.3 volt regulator, 1 little signal NeoPixel. And then when I plug this in, boop, it just does your standard dot star rainbow. So it's like, what is this good for? Well, I think that, there's this new Windows 11. I think I mentioned this. It's a Windows 11 dynamic lighting. Okay, so can you go to the computer? So there's this new thing where within Windows 11, there's an HID protocol for controlling basically NeoPixel devices. And so, look how they have learn.microsoft.com too. Everyone's got learn. And they even have code for Arduino and MacroPad, which is like great because it's like that's hardware that we make and use. And they're also going to have all these hardware platforms like Logitech that'll let you do synchronizing. And so I thought it'd be kind of cool if we had like a really quick board that you could plug in and then could do this Windows 11 lighting protocol, and maybe also could look like a DMX controller, and then you could just like plug in and have it manage up to 512, I think, LEDs within a DMX universe. So you could do like lighting without having to have like, an Arduino in the middle or something, because it was plug and play, and you could power it from the USB port. And then, so this works. It's not nearly as complicated as the TRRS Trinkey. I just have the power and ground come from the USB port, and then level shifted 2 pins from SPI clock and MOSI pins, so that I can do DMA NeoPixels on the MOSI pin, or you can do DMA dot star LEDs using the SPI peripheral. So that's pretty easy. And then one thing I'm thinking about, and it's just like I have to finish routing this board, is let's go to sorry, I'm on computer. One thing I thought it would be neat is I get once in a while these NeoPixels that are 12 volt or even like 24 volt power. And so I thought it would be cool if there was, this wouldn't fit maybe on a small board, but if you have USB-C, you could in theory request from the USB-C using a PHY chip to get the power delivery up to 12 or 20 volts. And so, there is this possibility of like, okay, I want to drive 12 volt NeoPixels and power them from USB-C. It could do this power delivery request and get you up to 20 volts. And then you'd have to, your power supply would have to be a little bit different, because the power from the USB wouldn't be 5. You would have to like have a regulator that could handle up to 20 volts input. But then, you could drive pixels that had this high voltage output without needing a separate power supply, because you could use just like a laptop power supply that give you up to 20 volts. So only thing is, like, this is still like, I'm still figuring this out, because I need to get rid of this 3.3 volt linear regulator, replace it with a buck, right? It gets complicated. So I'm thinking about how I want to do that, because I think it would be really useful to have it be USB-C and give you 12 volts. Because it's otherwise it's a pain. You have to get like separate 5 and 12 volt power supplies. It would also be maybe neat if you could have a quick switch that would just like, mechanically select one or the other. Anyways, so still thinking about this. Nothing quite done yet. All right, how are we doing on time?
15-minute mark.
Okay, great. Let's go to the great search.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Ladyada user power of engineer to help you guessy find something on digikey.com using her vast years of experience creating electronics, looking for parts. And this one is kind of internet famous at the moment, the Z80.
I know. We saw this come around. I was like, oh, this is a good one for the great search, because frankly, I didn't even know you could still buy Z80 chips. But so a couple days ago, April 15th, you file your taxes and you find out that the Z84C00 product line is end of life. Yeah, there's still products that are, probably white goods, automotive industry that uses a Z80 processor. So there basically is an end of life for the Z80. Probably because like the wafer foundry, I can only imagine the wafers must be like, 200, 300 nanometer process. It must be incredibly old process. And very few chips are using that process. And the places that are making these wafers and processing them are probably like, yo, we're not going to do this anymore. And we actually see this quite a lot. I remember there's been a few chips that I've seen from, I'm trying to remember which part it was from Analog, that they were like, not only not making this chip, but because there was, if you guys remember, like a few years ago, there was, I think some fires in Taiwan. I think, was it like in Taiwan? There was a fire in either Taiwan or in the Philippines, and a big foundry was damaged, like a big chip packaging foundry factory was damaged. And they were like, well, if we're going to rebuild this factory, we're not going to rebuild all the old processes. And so I think XP was also affected. A couple companies were affected, and a couple chips were like, hey, all of a sudden, like the factory we used to make them is no longer going to be, they're not going to rebuild that old machinery. So it's end of line. And also, like, I can't imagine that Zilog is selling that many Z80 processors. So this was the Z84. What was cool about it? It came in a dip format, which is just like so cool and so classic. It is last time buy, however, there are a bunch available. The last time buy date is sorry, I forgot to mention to go to the computer. But yeah, this is the Z84C008, 8 megahertz processor available in dip. They do have a couple thousand available last time buy. A last time buy is when you basically, if you are using this in a product and you really need, you're like, look, I need 3 years to transition to our design. Or if you're like, look, I want 10 years worth of product because I want to finish the end of the product line, and I'm guaranteeing 10 years. You can usually put in a request and say, hey, I want the last 10, 20,000, whatever quantity. And then what DigiKey will do is they tell Zilog, and Zilog will bundle up all these last time buys and do like, the final run. I will say that during the chip shortage, there were many times in which I put in requests for last time buys and they did not pan out. So not saying that's going to happen this time, but a last time buy is not guaranteed. It's a request. There is no guarantee that you'll actually get those chips. But again, part shortages were a rougher time. That said, if we go to embedded, first off, there are Z80 emulators you can get, emulators like, implementations for FPGA. So you can always mimic it if you need to. Although, to be honest, at this point, if you can move your chip to something else, please do. But under microcontrollers, first off, you can look under this series, and you can see there's Z8, which is probably related, or the core processor. Let's see if that's where Z80 might be mentioned. There's the EZ80. Actually, I didn't see this before. I wonder what that is. Looks like there's a couple other chips. So the EZ80 is probably, well, claim it's a similar family, not available in dip, but it is available. And some of these are discontinued, not for new designs. So let's look at ones that are, it looks like these are kind of fast. Let's look at active ones. So it looks like the EZ80, F91. These are all going to be, they're big chips. They're LQFP, big, and they're only 8-bit, but they are available. And it looks like they have, they come with peripherals at this point. Not USB, but they do have I2C and RDA. They do not have a lot of space. So, only like 256, ish. K and 8K of RAM. So these are not big chips. These are also not 5-volt friendly. So if you're looking for a 5-volt friendly, that's not it. But let's look for other Z80 chips. One thing I'll say is sometimes these microcontrollers are kind of split apart. Sometimes they're under microprocessors. So if you look here for the Z80, this is where you'll see like that Z84 series, which is last time buy. But they also do have some active. So again, if you select active, and you'll see these are available in 5 volts. So there's a couple of options. This one is 6 megahertz. This one is 10. Wow, super fast. Both are 5-volt friendly. They're available in 100 QFP. Let's just take a quick look at this one. But that is one thing I'll say is that, not every chip got discontinued. So this one is still available if you absolutely need a Z80 core. And yeah, it looks like Z80, multiple ports. It's a scanned PDF of a hand-drawn data sheet, which is like super cool. And I'm assuming that this must, implement this implements like the Z80 architecture. It's not going to be a surface mount part. However, you could solder this to a board that then has like 40 pins brought out and like adapted into like the pinout you would expect for a Z80 if you need to upgrade an existing Z84C chipset. So it's possible, but it's going to be more complicated than just like having the nice drop-in replacement. That said, you can still get a Z80 processor if you want, especially the Z84. So, get that last time buy, but you could theoretically use this chip and, like I said, just make an adapter chip, adapter plate that would plug in. And as long as you have all the peripherals that you were expecting and an amount of RAM and flash, you could program it as is. Something actually we did for the Zoxbox, we used a 64K flash chip that was DIP. It was the Atmega 64, and then eventually the Atmega, it wasn't enough space. People wanted the Atmega 128. I remember somebody made an adapter that took the TQFP Atmega 128 and brought out the pins into the 40 pin, like the 2x20 pin, 0.6 inch wide package, and people would plug that into the Zoxbox into the socket. So such things are possible, but you can still get active Z80s on DigiKey. So do that last time buy, or you can pick up one of these. It's my pick for the great search.
Where in the world is that part I need? The great search with DigiKey.
Alrighty, that's our show.
Okay,
Thanks, everybody.
we got to everything.
See everybody during the week. We have a bunch of shows from 3D printing to show and tell to ask an engineer to deep dive to all the videos we publish. Check it out on all the places every single week.
We're active.
See
We're doing
everybody
so
soon.
much. Bye, everybody.
Bye-bye.
Have a great week.